Right, hello, my name is Luke Sutton, N091370. Today I'm going to be demonstrating my AI code. Right, first things first, it's a chatbot about alcohol. Um, this is my little folder full of useful stuff, so it's going to quickly go through this. This is the tuning tests trials. This is where the data stored for the model. These are some of the lab stuff, old stuff. This is the main program, alcohol bot. This is the actual chat bot. This is the rule-based logical XML file. This is the training model for the image to produce the H5. These are some images, some test images you can use, which I've just labeled beer and not beer to show it's not beer and these ones are beer. Obviously this is the knowledge base and this is my Q&A document. Right, if we get into the code, if we come to the main chatbot, we've got all the libraries I've been using here, which is quite a few. Notable ones, NLTK, Keras. Right, so first things first, setting up the kernel, loading the model into the memory. We're opening up the CSVs and we're getting the question and answers from them. We're also starting the fuzzy system here, initializing it, and we're getting the knowledge base out of the CSV. So we're going to get a nice print statement at the start. It's going to come into it. First things first, we're going to go to the rule-based XML file. So if I just grab that real quick. So we're going to have obviously the basic categories here. Then we're going to have all the alcohol related ones. These are hard and fast rules, so if they type in alcohol, this is the only thing that's ever going to come up. They're just some rule-based responses here. And then if we come down, we can see the logical input ones, so the ones that have commands. So I know that is this for the task B. We've also got the cocktail API that I've implemented for task A. So that's an API that goes to, I think it's a database called the cocktail database or something. And you type in these set phrases and it'll take you to the correct command. So we'll go through that in a minute. And then obviously, if you don't get anything at all. Right, moving on. We're splitting up the answer so that we can tell if it's command or not. If it hasn't found anything in the rule-based system, it will come into here. This is where I've defined a fuzzy system. So basically, the idea of this fuzzy system is that it has 3 different responses depending on the sentiment and the word length that the user used. So if we just go to the rules real quick, if the user's like really positive and they're writing loads, then we're going to give them a nice response back because they're obviously feeling quite good. Whereas if they're feeling quite bad, like they say, "Oh, I hate alcohol" or something, and the word's like short, then we'll just give them quite a short response and say like, "Here, I have a result for you." So how this works is we define the fuzzy set here. So this is for sentiment. So sentiment can be between -1 and 0, but the gradient peaks at -1, and like favors it, and then the positive obviously peaks at 1. But it can be, so there's a bit of overlap here, which is why I use a fuzzy system. Then we've got word length in this one. So the word length between 0 and 3, and it peaks at 0. This one peaks at 5, this one peaks at 10. You can obviously see it's short, medium, long here. This one's negative and positive. And then this is the outcome response. So this one trends towards 0, this one trends towards 50, this one trends towards 100. So it's basically just the response level, and I use that later on to determine which response to use. Oh, I don't break code. Here. Right, the rules themselves, obviously, it uses the variable names. If it's positive and this is long, then you get this, which is quite self-explanatory. We add all the rules to the fuzzy system. Then we split up the user input to words using the tokenize bag of words. Then we get the sentiment score. So basically, I've got this opinion lexicon from the corpus set of data, and it has a list of positive and a list of negative words, and it will increase or decrease the sentiment depending on the average sentiment over the whole sentence. Then the word length is simply just the sum of the words divided by their length, obviously to get the average word length. Then we call the fuzzy system. So we actually do them down in inference, and we get a result. And then obviously, as I've stated before, depending on the numbers, it gives you a certain result. Then we move on to the actual Q&A CSV part. So first it will lemmatise the user input. So it's going to reduce the word down to its base form. So if we go from like cats to cat. Then we make it to a vector, which can then be used later on to find the correct thing. So this is for the user input, obviously, and then we're going to do it for the questions here. So yeah, for every question we go through, we lemmatise it like we did with the user input, and then we also vectorize it, and then we compare them. So we see if the two vectors are similar. The most similar one gets stored in the max, and then obviously at the end it gets out the max one, or if it hasn't found anything similar at all, it's saying sorry, I don't know the answer. Right, moving on. If it's a command rather than the chatbot doesn't know what it is, it will come down here, and it will split the parameters up into the command itself and the user input. This is just an empty command. This one, okay, this is for task B. I know that star is star, so it will come in here. It will get the object and the subject by splitting up the parameters over is using the delimiter. It will read the expression by putting, actually it won't read the expression, it will put the expression together by using the subject and the object from earlier. It will construct a first order logic expression, and then it will also construct the negative version of it. Then we try and prove to see if the negative expression is in the knowledge base, and if it is, then we can't add it, and it will say you can't add it. Otherwise, we're going to append it, and we're going to say we'll remember that. Right, moving on, we'll check that. So check that similar, doing the same thing. We're proving whether it returns true or false. We're printing correct, or printing. Well, we're then going to check if it's negative or just unknown. So this one will check if it's negative or unknown. If it's negative, it will give you that. Otherwise, it will give you the unknown value. I also did what do you know. So this will just print the whole knowledge base just in a simple string format using this. So we'll go through and change it all to fit the correct human readable stuff. So that's for the application expressions. For the input expressions, it will just print it because it's really hard to format. Right, check my image. This is for the model for task C. Basically, this opens Tkinter, the Python library, which then allows the user to select a file. And then using that file path, we can resize it to the correct size for the model. Then we're going to expand the dims. Then we're going to use the model to get the prediction, get the classes, and then if the class is 0, it's going to contain a beer bottle, else it's going to not have a beer bottle. Moving on, we're now onto the API stuff for task A. Ingredients. So this was, if you type in ingredients, it's going to ask you for an ingredient, so you can put like vodka. It's going to send a HTTP request to the database. It's going to get back data, we're going to decode it, we're going to load it, the JSON, and then we're going to get the description of it, and we're just going to print out the description. Else we're going to print, we can't find the ingredient. Popular cocktails are similar, so we're looking for the most popular cocktails that's on their database, so it will just print out their most popular cocktails, but basically doing the same thing. Similar again with random cocktail, except it will obviously use the random function built into their database, and then print that, and then 10 random cocktails is just the same again. Right, so that's the most of this file done. If we move to the trading the image, for the image, then we can move to this. Okay, so this is all about TensorFlow and Keras. We set up the image data generators, which are going to be useful later on. We have a train generator here, so it's going to specify the directory of where the data is. We're going to have the target size of the images, the batch size of how many are going to get done at once, categorical data, and we're also going to have the two classes that are in my folder. Let's just show you that real quick. So if we go to data, you can see test, train, validation. For each one of them, we've got beer, which is beer, and not beer bottle, which is just loads of random stuff, which I found from this database online, and then took a certain amount of them out. That's similar for test and validation as well. The same goes for the test generator, it's just a different folder, and then for validation. We're specifying the hyperparameters here, so this is a bit of extra stuff I did for task C. So the optimizer can be between the Adam optimizer and SGD. The learning rate is obviously the step size. Then we've got the filters, so what these hyperparameters will do is it will choose a random value between 32 and 256. Well, it will test them all out with the tuner, which I'll explain in a minute. The same with the kernel, it'll give you two different values, and the hyperparameters will sort themselves out by testing it. We've also got the dense layer, something similar, except it uses less. It uses more of a minimum value, you can't use a lower number. And then we got the dropout, which is how many are randomly dropped out per layer. Right, moving on to this. The input layer, this is the shape it's originally coming in. 3 is the amount of channels for the RGB, because obviously it's an image, it's got 3 different colors. So I went with 2 sets of convolutional layer and then pooling. So it uses the filter for the hyperparameters, and that will decide what values these are, the optimal choice. Obviously the kernel size is used for that as well, and the activation is the ReLU activation function, which is the one where you can't go below 0. It does that again here, and then we're going to pool again, and then we're going to flatten it out. Then we're going to randomly drop some of the data values, minimum being 0, maximum being 0.5, like we said before in the hyperparameters. Then we've got a dense layer, so that's a fully connected layer, so we're gonna then connect the input with the output, and then we've got this dense layer here with 2 units, because obviously we've got 2 categories. We've got a softmax so that it can deal with the categorical data. The optimizer, obviously the learning rate is defined up here. This time we're gonna use Adam. We want to use categorical because we're obviously using categorical data and we're measuring the accuracy. I'll show you the output of all this in a second once I've gone through it all. The tuner, obviously this is just setting it up, so it will do build model whenever the tuner is called. So obviously when it's testing the hyperparameters, it does 5 tests beforehand, which is specified here. It'll put them into this folder, and then it will choose the one that gives the best value and accuracy, and then use that for the actual model. So then it'll do 10 epochs of the actual model. Yeah, so this is then going to call, I had this set to 5 epochs earlier, I've changed it down to 2 because it was taking so long. It was taking me about an hour just to go through all the hyperparameter stuff. Then we use the best hyperparameter training to fit the model. Then obviously we get the predictions from the model. We separate it to the class labels. So then we can assess the true versus the prediction using the confusion matrix and the report. We can also get the test accuracy, and then we save the model. I will quickly show you what that looks like. I think I've saved it somewhere. If we go here, I did have my notes in my report, 1 second. If we open up Presentation. Here we go. I'll quickly show you. It looked like this, the output. So obviously we got the running trials, 1, 2, we went to 5. So for each one, it shows you the best values so far. So this was 96 because it was the first one. Then you can see that it tried 192, but 96 was better. We went through this. Obviously, you got each epoch, the steps, how long it takes, value accuracy. We're aiming for the highest value accuracy during the trials. Once the 5 are done, shows you the best value accuracy so far, and then it will use that to then do the 10 epochs of normal stuff. And then obviously you get your confusion matrix, and then all your analysis at the bottom, and you get a nice little test accuracy. So that's basically the model complete. So that's all of the code gone through by itself. We can also quickly have a look at the knowledge base. So the knowledge base is literally wine is alcohol, beer is alcohol. These ones are beer is not wine, spirit is not wine, wine is not spirit, stuff like that. It's just not displaying because Excel is annoying. Q&A, obviously questions and answers. So this will be the one that has the fuzzy logic and also the what you call it, techniques to get as close as possible, and it will assess the similarity. And then we've also got, I've shown you the base images. This is the H5 file produced by this training program. I think that's everything. So I think I can go through and show you what everything does. Right, let's run the bot. Run. Okay, we'll quickly go through. So we'll start with task A. So we're just going to do hi. These are the rule-based AML things. Good. How are you? Okay, nice. We can ask if it likes to drink alcohol. If it doesn't, I can say like I like popular wine, and it respond back. Nice. Okay, and then we got the similarity-based stuff. So, what's some common types of beer? Takes a little bit longer because we've got to check through. It'll give you just a basic response because I haven't used any like happy words or sad words. Lagers, ale, stouts, IPAs. Nice. Okay. So like I hate kegs. I don't know why, but we then use. Let's do this. There you go. Because I've used hate, it gives you like the here sympathetic response. What else can we do? We could just type it in Moscow and see if it works. Yes, so it will give you the result from the Q&A, and then also just put in a happy word and show you I found an amazing result. There you go, nice. Okay, and then the API, popular cocktails. I won't show you all of these because otherwise it's going to take ages. So these are the popular cocktails. Random cocktail. There you go, orange push-up, ingredients. Let's do gin. Bang, you get a whole description of gin. I think that's most of task A shown there. Okay, then we're going to do task B. So this is the knowledge-based stuff. So what do you know? Should show the whole knowledge base. There you go. Check that Carling is beer. That's correct. That's case insensitive as well, I think. I know that drinking is bad. Okay, it's going to remember. And if we show the knowledge base again, it's in there at the bottom. There you go. Drinking is bad. And then if I do, I know that drinking not bad. It's going to be like contradiction. That's already in there. It's not going to let you do that. And then if we do check that with some, it doesn't know. But if we check the thinking bad, it's correct. Or if we check the thinking not bad, so this is incorrect, which is perfect. Then if we do check my image, it's going to pop up with this. There you go. And then if we go to images, where did I store it? Here. Okay, here you go. You can see them already. So we go this one. Image contains a beer bottle. We'll do one more. Oh, that's going to type correctly. Image. Back to here again. The elephant. There you go, beer bottle not found. You can try that with any image, and it should work. But I think that is most of the functionality covered. I've gone through everything in both files, and everything else is there. So thank you for listening. Sorry it's been so long. Thank you.